Today we will continue with our unit 4, and in this session we will going to understand about the query execution plan. So as you have understood the process that how we will execute our query, like first that particular query will go inside the parser, and after the parser it will go into the query optimization part, like the query optimizer, and in that particular query optimizer we create some query execution plan. And we have heard about the query execution plan, that what is query execution plan. So let's start with this topic. So in this session and at the end of this session you will be able to define what a query execution plan is, that what exactly this particular plan. Next, you will be able to differentiate between logical and the physical query plans. That means if we are creating the query execution plan, there are two types of plan: logical plans and the physical query plans. So we will also try to understand about the logical and the physical query plans, that what are they. Next, we have, at the end of this session you will be able to understand how a database generate and select the best plan using cost estimation. So we will understand about the cost estimation, that how we are selecting those plans. And next, we will going to use some tool and like explain in MySQL and Oracle to visualize execution plans. So meaning over here is, if we are visualizing the execution plans, so we will see that how we can write the code to see that what exactly been going on in this particular query execution plan. So let's start it. So first of all we will start with our QEP, which is query execution plan. So the first point is, a query execution plan is the internal roadmap. You have to look over here, which is internal roadmap the DBMS uses to execute the SQL query. So if we are trying to execute our particular SQL query, so this is the internal roadmap. You can understand the roadmap, right? In the roadmap what happens, that we have multiple streets, right? And we have a particular map, right? How we have to go step by step. So this is actually the plan, that how your SQL query will going to be execute. Next, it includes operations like scans, join, sorts, filter, and their order of execution. So in which execution plan we will decide that how the scan will work, join, sort, and filters, right? And we in this DBMS will also decide that how and what are the order of execution, that how those particular operations will be performed in order. Next, it helps understand and optimize query performance. So if you want the query performance and if you want to optimize the query performance, because we know that we need a really good performance of our execution of our query. So for that what we need this QEP, query execution plan. Because as you know that after selecting we will create the multiple plans, and from those plans we will select the best one and the efficient one. So why do we need the QEP? Because a query, SQL query, can be executed in multiple ways. So we have multiple ways to execute our particular query, but there are multiple ways, but one can be efficient than another. So DBMS chooses the most efficient one. So for example, if we have multiple ways like 1, 2, 3, 4, and if the fourth one is the best way to execute that particular query, and that will be the efficient, then your DBMS will select that particular way, not these ways. Next, it helps us, or it helps with performance tuning, so we can improve our performance. Index evaluation, we can see that we have to do a full table scan, or we have to apply the indexes, or if we are applying the indexes, how we can evaluate for the better performance. And deleting slow queries, that means a query can be slow, query can be complex, so we can delete those slow queries and execute them in a faster way. So let's see. Now we have two plans. Okay, we have talked about the plans. So in the query execution plan, we have two type of plans: logical plan and the physical plan. So whenever your SQL query executed, so what happened that your logical plan created first. Okay, in this logical plan, we talk about the operations, we talk about the relational algebra, and we convert SQL in the relational algebra. In the physical plan, we talk about how those operations are actually executed. Here, operations are not being executed, but we are talking about what operation we need, right? Here, we talk about the algorithm and their access methods and scanning methods like index scan, full table scan, or join orders. So, what happening over here? Now we are talking about the differentiation between the logical plan and the physical plan. So what will happen that first of all, if you are executing your query, a logical plan will be created. Based on that particular logical plan, we will create the multiple physical plans, and from those physical plan, we will select the efficient one. So here aspect, what it shows what operations needed to be performed, and in physical plan how those operations will be executed. Next, based on which it is based, the logical plan is based on the relational algebra. Okay, so SQL now has converted into the relational algebra, and this relational algebra, this is actually based on the relational algebra. That means it actually observing the operations from the relational algebra expression. And then if we are talking about the physical plan, in the physical plan we have algorithms over here and access methods. Okay, because we are talking about how the operations are executed. So whenever you will see the how the operations are executed, that means we have to show what are the steps, and what those steps are actually included in the algorithms and explained in the algorithms and with the help of algorithms. What are the examples? For example, in the logical plan, you will convert a SQL query where you are selecting the name from the student table where marks क्या है? Marks is greater than 80. Okay, so here in this relational algebra, the marks is greater than 80 and the name is greater than. So we will select the name of the students. The optimizer turns a logical plan into the best physical plan. So what component we use? We use the optimizer for it. Let's see our next. So as we are studying the query execution plan, so now we are talking about the components of a query execution plan. So you can see the various components of query execution plan. The first one is table access methods. So if we are talking about the table access method, so we have two types of scan, full scan and index scan. What is the meaning of full scan? For example, if you have this table and you have roll number of students and their name and their student name. So you have one and then student name is something, and then think about it, you have thousands of students. So the last record is in the table is 1000. Now if you want to reach this particular 1000 students, so if you are doing the full scan, that means you have to go through every row by row, and then at the end you will going to reach this particular student which is at the place 1000. But if you are talking about the index scan, so what you will going to do, you will going to create another separate table for this particular table, right? And then you will going to create a pointer for it, and the value for it. So for example, if you want to search the 1000, so what you will going to do, you will going to write the value 1000, and this particular pointer P1 will going to point this row over here. So once you will execute by using the index scan, then this particular pointer will point directly to that particular row, and then you don't have to process all these rows from 1 to 999, right? So this is your index scan. Again, understand that you have to do the full table scan when the table is small, because if you will use the index scan, it will be complicated, it will take more memory, right? So this will be not efficient in the case of low data or low range data. If you have a larger data set like 1000 millions, the 1000 is good, but if you are talking about the DBMS where you have the millions of records, so in that condition you have to use the index scan. But if the data set is small, then you have to use the full table scan. Next, we have the join types. So in the QEP, we also considered about the multiple join types like nested loop join, merge join, and the hash joins. Next, we will consider the filter conditions as well, the conditions you use in the queries, and estimated cost, rows, and execution order, that what will be the order of execution, what is the estimated cost, and rows, that how many rows are processed in the table. So these were the components, and now we have to see that how the DBMS generate this query execution plan. So first phase, we have already studied that. First, what we will do, we will take our SQL query and then send it to the parser, right? So parser will create a parse tree. That particular parse tree will go inside the query optimizer, and then we have to convert our SQL into the relational algebra. So in the parse tree, we check the syntax errors plus the semantic errors. So we check 2 errors over there. After that, we will convert our SQL query into the relational algebra. Then optimizer will apply rules and statistics. After applying these rules and statistics, then we will create multiple candidate plans for the execution. So now in this phase, you have created the multiple plans, and after those multiple plans, now we have to select our best plan to execute that particular query and reject those which are not efficient one or the best one. So here, how we will going to select that particular plan? By using this cost based optimizer. Okay, now we will see that if we have the multiple plans, so they incorporate multiple cost with them, right? Multiple type of cost. So how we will going to conclude or calculate that particular cost? So here is the cost. In the cost, what we will going to do, we will consider input output, that query will go inside the memory and then you are taking the data from the hard disk again. So this is input output, then CPU cycles and memory usage. So all these will be calculated by your DBMS. You don't have to worry about the calculations of the cost, but your DBMS will do for you, and in the MySQL workbench you can also see this cost. So once it will calculate, then DBMS automatically decide that which plan is best for the execution of this particular query. So example query and QEP, that what is the example? Suppose you have this particular query. Select name from a student where marks greater than 80. So if we have marks greater than 80 over here, so you can see here is the condition. We have this data source student on which on every row we are applying these conditions. and then we are selecting this name column from it. Now what are the possible execution plan? We can apply the full table scan for it, we can apply the index scan on the marks column, or we can use filter and the projection. So what is the execution plan? That means we are planning this. We will apply the full table scan, we can include the index for marks, and we can also use some filters and the projection. Let's see if you want to see the execution plan. So how you will going to see this? So first you have to write down the explain and your whole query. Select name from student where marks greater than 80. Then what will be the output? By using this particular explain keyword, now this query will be explained by the DBMS to you. So this particular output you will see that ID will be 1, okay, and the select type is simple, we are selecting the simple. Then we have table, the name of the table is student, and what is the type? Type is equals to range, that we have this range. Key, what kind of key we are using? We are using the marks key, and rows will be processed as 100, and extra, what is extra? Using where, we are actually using the where clause. So index on marks is used and fewer rows scanned and efficient plan. So by using this we have made our efficient plan over here. So index on marks is used, that means if we have used the marks index on the marks, so we have to search the fewer rows, right? And if you have used the fewer rows, you didn't have to do the full table scan. And just think, in this student table we have the millions of records or the larger data set, that in that condition this particular plan is efficient. Next, how you will going to do this same process in the Oracle? So in the Oracle you have to write down the explain plan, and then you have to use for. So the syntax in the Oracle is this: explain plan for, then you have to write down your query. Select name from student where marks greater than 80. Then what you will going to do? Select star from table DBMS explain dot display. So by using this display property of the DBMS explain or the package, what you will going to do? Now you will going to see the table for this particular plan. Okay. So what will Oracle will show? Oracle will show the operation hierarchy, that what is the hierarchy of the operations, what is the cost or estimation, right, which have concluded by the DBMS, what are the row counts, and the predicate filters. Predicate filters, that means what are the conditions that you have used. So these will be shown by the query optimization, query execution process in the Oracle. So now this is about the tools, that what are the tools you can use. So if you are using MySQL on the Oracle or the PostgreSQL, we can use the multiple tools. So first one is MySQL. You can use MySQL, or for the QEP you can use explain and the analyze. Next, in the Oracle you can use explain plan and DBMS underscore explain. Okay. Next, PostgreSQL. In the PostgreSQL you can use explain, and in the brackets you can use analyze and the details of buffers. So in the PostgreSQL you have to use this syntax, and if you want to see with the graphical user interfaces, so you can use MySQL Workbench and the Oracle SQL Developer. So you can try all these tools. Now this is the time for your assignment. So first what you have to do, run an explain command on the following. So now I have given you these two conditions, that first you have to use a query in which you have used the select clause with where clause. Okay, so this is your explain command. You have to use this with this particular query, and then you have to join between two tables. So for example, you will going to create two tables, then you have to try join those particular table. Once you will try to join that particular table, try to use this particular explain command over there and see the execution plan, that how it is actually performing internally. Next, now you have to write down and note down the difference when using indexed column. For example, if you are using a query and in that particular query you are using indexes, so what you need to do, you have to see that what is the difference, right? If you are using the index based columns or the without index based column, and then using non index based columns, right? And you can submit your screenshot of output with interpretation. So you can share this thing with my mail, which is akshar.gupta@jnujaipur.ac.in. So you can share with me your screenshot of your assignments, and then these are the takeaways, that what do we have learned in this session so far. So first we have learned about that the SQL query shows how query will be executed. QEP shows how a query will be executed, not just what it does. Okay. Next, databases created multiple plans. Okay, we will create the multiple plans, or the DBMS will create the multiple plans and choose the best one based on the cost. Next, we can use the explain and to related tools to understand and improve the query performance. And next, we have understand that QEP is essential for performance tuning and efficient database design. So thank you so much for your attention and best of luck.